there, everybody. My name is Collin and this is my Physics 2211 Lab 4 Oscillations Lab. So, getting right into it, my introduction. Our purpose is to analyze a spring bouncing up and down and comparing it in two dimensions, comparing that to some code. This is a whole big list of our physics ideas, which I'll go over in a second. And then this is what my code ended up spitting out when it was all said and done. The red line is the experiment, the blue line is the model. So these are our main physics ideas. Here's the equation for position update. Here's the equation for velocity, potential of gravity, force of gravity, potential spring, force of spring. We need our position update to be we need to be able to simulate that. So we need to loop over our position update. For that, we need a velocity update, and for that, we need the force of gravity and the force of the spring, which are our two forces acting in our system. We also need the potential of spring, potential of gravity, so we can compare it to our tracker data. So in our video, my system is the Earth, spring and mass. We don't have any surroundings. Ball mass is just there. There's our starting stuff. And this is the video. How engaging. Alrighty. Next up is the code. And then, so we have our starting things up, initial conditions up here again. We have a gravity constant, our spring constant, and our relaxed length of the spring, which is calculated by these guys that I just made into a number. So then we are our starting conditions for our force of the spring. Then we enter our while loop. Then we have our spring equation, our F net equation, and gravity's up there too, but he's not included. Then we add those two guys together, and then we do our velocity update, position update, and then we update everything again. And then down here we are finding the potential of all of our forces, and then later we can compare these right here to these guys. Well, that's not exactly right, but this is what all this code spits out when it's just plotting the positions versus, once again, the experiment is the red line and the blue line is our model. So it looks a little funny there, but that's okay. So for places of some possible error, the delta t might have been too large. So for our experiment, we did a really small delta t to calculate everything. Or I might have started it wrong in tracker, or maybe Dr. Grieco accidentally applied some force when he let go of the spring. So going into our what if questions, this is actually the change in energy versus change in time. So we see, is the energy principle satisfied? So the weird thing about this is that there should be an orange line going across and a red line going across. So at first glance, it looks like no, they're not. They're not all evening out, but in fact, they are all evening out because the line's not shown because it's not changing, and so delta grav is not changing, so it's missing, and delta E is not there because it's also zero. It's constantly zero and it's never changing. So I guess Glow script didn't feel like plotting it. All right, and then we want to make two separate estimates of the oscillation periods. So if you look at the actual tracker data, you can find the place. This one was easier to find. You find where it was the lowest at the lowest point, and to compare it to each other. These are the times at all of them. You subtract and then divide. You get about 1.6 seconds. And this is the point where the spring was the furthest to the left. So then you have all of these numbers, and then you find the difference in between each one, and then you get this. So they're about the same, which is good. And that is all I have. Thank you for watching. I hope you have a great day.